How we doing, guys? We're looking at normal probability distributions here. So this is something that's more accurate than the empirical rule we saw in the last video. But just to go back on an example, if you were given a normal distribution like this one here, and you were told asked what proportion of values will lie between -1 standard deviation and +2, you might have said, well, my empirical rule tells me that this half of 1 standard deviation is 34, and this half of within 2 standard deviations, half of 95 is 47.5, which would have said 81.5% of values lie between 1 standard deviation below the mean and 2 standard deviations above the mean. The way we're going to write that now is to say the proportion, rather than the percentage, of values that have a z-score which is greater than -0.1, so z is greater than -0.1, that's all of these, but less than +2 is equal to 0.815. Okay, and we normally work to 4 decimal places here, so I'm going to stick a 0 in there. And that's how we'll phrase this now. Okay, so we're talking about proportions, or the other one you'll hear an awful lot is the probability of a given value lying within between a z-score of -1 and +2 is 0.815. So those are the two things that you hear: proportions or probabilities within 2 standard scores. Now, let's look at another example. If I were to give you, I'll actually draw this out quickly. So I've given you the same diagram, and I'm just asking you now, well, what proportion of values lie between the mean and 2 standard deviations? And hopefully you'll say 47%. And what proportion of values lie less than 2 standard deviations? And you'll say, well, this being a symmetric distribution, exactly half of the values are less than the average. So that's 50%. Okay, so what you get there is that 97% of your values, sorry, that's 47.5, wasn't it? So 97.5% of your values lie less than 2 standard deviations, or the probability of a standard score being less than 2 is 0.9750. Okay, or equivalently, the proportion of standard scores in any normal distribution that is less than 2 is 0.9750. Now, if I point you towards page 36 in your log tables, you get these probabilities for normal standard distributions. Okay, and you can see all of the z-scores listed down here. Okay, so if I go down as far as 2, look, it tells me there that within 2 standard deviations, 97.72. It's a little bit more accurate here in the log tables, but 97.72% of values will be less than 2 standard deviations. And you just remember that our empirical rule is an approximation. And yeah, if you're really being accurate with that empirical rule, the value is 1.96. You'll see this 1.96 come up later, and it's a really regular number in statistics. 1.9 is here for my z-score, and then if I want the 6, I come over here. 1.96, the proportion of values that will be less than 1.96 standard deviations above average is 97.5%. Okay, so these normal distribution tables is what we're going to use from now on to calculate our probabilities in this exercise. And what these tables always tell you is the proportion of values in a normal distribution which are less than a particular z value. So in our last case, less than 1.96, the shaded area represents that 97.5%. So the shaded area represents the proportion of values which are less than a particular value, or very often the probability that a given value will be less than. Okay, and those kind of get used almost interchangeably here. Now the book jumps straight into these type of abstract questions. I'm not a huge fan of them. I prefer the examples. I'm going to do 2 and 5, and then we'll do some examples, and we'll come back to these ones now. So question 2 says, find the probability that a given z-score would be less than 1.42. Or less than or equal to 1.42. Now, what I'd suggest is every time you do one of these type of questions, you sketch yourself up a little mini probability distribution like this. Just shade it in, What are they asking you for? Values less than 1.42. For this one, it's really obvious that it's the same shape that you're given here. Okay, so we can just follow our tables, no problem. Look for a z-score of 1.42. There's 1.4, and there's the 0.2 you add on, and the 0.02. So 1.42 corresponds to a probability of 0.9222. 0.9222. Now that's really easy when they're asking you for a z-score less than a particular value, less than a particular positive value, I suppose. For question 5, the probability that a given z-score will be greater than or equal to 2. And that's now this shaded area to the right, okay? And that's not what the log tables give you. They give you the shaded area to the left of 0.2. So if I look up 0.2, I get a value of 0.9772. That represents this white shaded area to the left, 0.9772. Now, the total area under the curve, or the total probability of every possible thing happening, is 1. So you'll just say that small shaded area is 1 minus that 0.9772. Okay, and a question that I'm always being asked by students is, I don't know, when do I do a 1 minus, or when do I not do a 1 minus? And the answer is draw a diagram, and you'll get very used to this as you go. 0.0228. Okay, so less than 2% in percentage terms there, or sorry, just slightly more than 2%. Right, I'm going to look at an example before I come back to some more like this that has a little bit more meat on it. Okay, question 28 here. The chest measurements of teenage male customers for t-shirts may be modeled by a normal distribution with a mean of 101 centimeters and a standard deviation of 5 centimeters. So this is t-shirt sizes. Find the probability that a randomly selected customer, so any one person from a very large group, will have a chest measurement which is less than 103 centimeters. Okay, so here's our normal distribution. We've got an average of 101 centimeters, standard deviation of 5. No harm in actually including one standard deviation above is 106. Excuse me, 106. 2 standard deviations is 111. 3 standard deviations is 116. 1 standard deviation below is 94. I'm subtracting 5 here. 96. 2 standard deviations below is 91, and 3 standard deviations below is 86. Okay, so you can kind of see where most of your data lies between 86 and 116. The probability that a randomly selected teenager has a chest measurement less than 103 centimeters. So find this shaded area. That's what you're being asked there. So what you need to do first is standardize this score of 103. So you say 103 minus the average score of 101 divided by the standard deviation of 5. Okay, remember that's x minus mu over sigma. That's how you get your z-score. And so our standard score here is 2 over 5, or plus 0.4. So that's what's being asked. What proportion of teenagers have a z-score which is less than 0.4? And we know how to do that. Let's look up your log tables. 0.4. 65.54% or 0.6554 as a proportion. I'll leave it as a proportion, 0.6554. In fact, the question asked what's the probability. So again, probabilities are between 0 and 1. It is interchangeable though to say that's a 65.54%. The next part of this question then says, what is the probability a randomly selected customer has a chest measurement which is 98 centimeters or more? Okay, so that is a customer here, 98 centimeters, who's below average, but is greater than that 98. Okay, so let's have a look. What's the probability that a customer has a chest measurement greater than or equal to 98 centimeters? You follow the same procedure. Standardize that 98. 98 minus 101 over 5. That's minus 3 over 5, or minus 0.6. Okay, but again, always good, sketch out as you go, loads and loads of these diagrams. Minus 0.6, you want the proportion of people greater than minus 0.6. Now, we haven't seen how to do that. Okay, so we don't know how to do that for the moment, but remember this is a symmetric distribution. So that's going to be the same as the proportion of people who are less than plus 0.6. Okay. Okay, and another good question to be asking yourself as you go here is, well, actually, don't worry about that. Less than plus 0.6. Go to your log tables, plus 0.6, that's 0.7257. Okay, so the proportion of people who have a chest measurement greater than 0.98 is the same as the proportion of z-scores in a standard distribution, which will be greater than negative 0.6, which if you want, you can also say is the same as the number of z-scores, which will be less than plus 0.6. But either way, your log tables told you that was 0.7257. Okay. Now, I'm not going to do part 3 here. I'm going to go back and do one more example of the kind of abstract ones. Okay, I'm going to do question 12 here. Find the probability that a standard score would lie between -1 and +1. Now, that's our empirical rule. We know our answer is going to be 68% or 0.68. But let's see how we can get that doing a calculation. And that way you're going to be able to do 13 and 14, which are the same type of problem as well. Okay, so I've got 2 diagrams drawn out here because we're being asked to show the proportion of values that are less than +1 and greater than -1. So in order to get this area here, okay, remember my log tables tell me the total area less than +1. So that's including this little bit over here. So in order to get the bit that I want, I'm going to say, well, what is the proportion that's less than 1? Okay, the proportion of z-scores that are less than or equal to 1. And then I'm going to subtract this extra little bit over here, which I'm including down here, the proportion of z-scores that are greater than, that are less than or equal to -1. Okay, I want to take that away from it. Okay, so if I look up initially my log tables, I say, well, the total shaded area, including this extra bit here, probability that z is less than 1 is 0.8413. So that's probability that z is less than or equal to 1, 0.8413. Whereas down here, this small bit here, well, yeah, the log tables don't tell me that. But remember, this is equivalent to the proportion who are greater than +1. Now, is that any easier? The log tables don't tell me that, but they have told me that this bit is 0.8413, haven't they? They just told me that a second ago up here. So this bit here is 1 minus 0.8413. So the proportion of z-scores greater than +1 is 0.1587. Okay, and what you need to do now is you say, well, the bit I'm interested in is 0.8413, okay, this total area, minus this area here, which I've just worked out, is 0.1587. So the proportion of values that lie between -1 and 1 is 0.8413, take away 0.1587. Okay, and how do I get there? 0.8413, take away 0.1587, 68%, just like I predicted from my empirical rule, 0.6826. Now, just to make the point again, people always ask, I never know, when do I do a 1 minus, when do I not? There's 2 ways of thinking about it. You do a 1 minus if your answer is less than 50%. So here, where it was really obviously less than half of your total area, you do 1 minus, whereas up here, where it's really obviously more than 1 minus, you don't do, where it's really obviously more than 50%, sorry, you don't do a 1 minus. But really it's draw a diagram, okay? Draw these out. You're constantly drawing these out in this section. Get into that habit and it'll hopefully get this straight in your head pretty soon. Okay, so as well as making sure you got 2, 5, 28, and 12 taken down into your copy there, can I also ask you to go and do questions 1, 3, and 6 yourselves? Okay, see you next time.